Okay, so hello everybody. This is a demonstration for Omixon Target. It's going to be a short demonstration for 15 to 20 minutes, and I'm going to introduce a few of the features of Omixon Target and show one or two of the concepts behind the tool, and also talk a bit about why we've built it. My name is Tim Haig. I'm Omixon's Chief Technology Officer. I'm going to give you a quick demonstration today. So you should be able to see in front of you the Omixon Target login screen. Actually, the very first time you use the application, you will be prompted to register into the application, and after that, each time you want to use it, you will need to log in. This is an order that we can keep track of for an audit trail of who's been doing what within the tool. So I'm just going to log in. All right. Oops. Okay, so this is the first thing you see when you log into Omixon Target. We essentially have three main functions within the tool now, and we've split things up into to make it a bit simpler to use. So we have a data analysis function. This is for sort of general genomic data analysis with diagnostics in mind. We have a HLA haplotyping function. This is only for doing for calling HLA haplotypes within NGS sequencing data, and we have some settings which are sort of system-wide, which allow you to change a few of the settings within the application. So I'm going to start with a very quick introduction of some of the navigation features within the tool. So I'm not going to explain what these screens are yet. I'm just going to quickly show how some of the navigation works, because I think it's quite useful to understand how to navigate. So I'm going to go into the data analysis part of the tool. And as soon as I've done that, there's a few navigation options that have become available. So one of them is the home, which will always take you back to the home page where we started. There's also a sort of a web browser style forward and back buttons up here, which can move you around. Plus, as you drill down into the tool, at any time you can go up a level by using this button here, which in this case will take us back to the home again. So this is the data analysis dashboard. I'm just going to select one of the experiments here by clicking on it, which takes me to the experiment dashboard. And just to show one or two of the features, the navigation features in here, I can also use the title bar at the top here to navigate around. I can go backwards and forwards just by clicking on the breadcrumbs at the top of the navigation feature. And if I select a different experiment, this one here, I'm just going to select an analysis. We've got a list of some items in here. So on this side, we've got a few list handling facilities. So you can select individual items in order to do things with them, or you can select them all with this function, deselect all, or you can swap the selection around by using this function here. So this is some of the list handling functions within the tool. Something else you can use is a little bookmarking function. So at any time, if you want to, you can set up a new bookmark for where you are in the tool. So you can create this one here. So this is my HLA analysis. So if I go back to the home, I can use the bookmark to jump back again. Oops, didn't select it. I'll just close. Sorry, that's this one. To jump back to the HLA analysis where I set the bookmark in the first place. It's also worth noting that most of the screens within the tool have a help function. So at any point as you're navigating around, you can click on the help and get some sort of text-based help to tell you what's going on and where you are within the tool. And the last couple of high-level functions are all in this corner here. So the very first time you use the tool, you'll be presented with a welcome screen. We haven't quite finished the text for this screen yet, but this gives you a kind of a high-level introduction to the tool, a bit similar to what I'm doing now. You'll be able to read through the little welcome wizard, which will introduce you to the tool, and then any time you want to see that again, you can just click on this little button up here, which will show the same thing again. This button will log you out, and this button will turn off the tool. The last couple of features which are available everywhere, we have a little task manager to show analysis tasks that take a bit longer, that are running in the background. So you can see how those are doing. You can abort tasks and do things like that in this function. And this one up here gives you a full screen function and will hide most of the menus and other things, so that you can get a bit more, you can see a bit more what's happening within the tool. Okay, so that's sort of it in terms of a very general introduction to some of the navigation features. So to go back to the home page then, I'm going to start by showing the HLA haplotyping feature for Omixon Target. Now this is a brand new feature. This is something that is going to be released in this version in July. So I'm going to go into this feature. This takes you into a haplotyping dashboard. There's a very simple setup for this, where you select which sequences you would like to work with from the list of sequences, so Illumina for example. And then the next step is to actually import and profile some data for this the haplotyping engine. This will basically configure the haplotyping within the tool. So in fact, it's enough here to select your sequences and press finish, and that's all you need to do to set up the haplotyping engine within the tool. This will download a small database and install it within the tool for you. So once you've set up the haplotyping, you can then run it using this feature here, HLA haplotyping. So I'm going to do this right now. So you have to give your little analysis a name, so I'll call it demonstration. And the way this works is it takes NGS short read data, and basically you can import and haplotype this in a single step within the tool. So this particular data set is it's fairly deep sequencing. It's only targeting 4 of the HLA loci, HLA A, B, C, and DRB1. And this was prepared on an Illumina MySeq with paired read data. So I'm selecting one of the FASTQs. Because this is a paired data, I select the other FASTQ here, and I can set up the usual sort of paired data options, the distance that you expect between the reads and the orientation of the reads with respect to each other. I select my species, which is human. Sequencer, I pre-configured this one to Illumina, and some advanced options you can set in here. This is how many reads the haplotyping engine will process. Depending on your the type of sequencing that you're doing, you may need to set this value a bit higher. So if you're processing a wider data set with, for example, the rain dance HLA-seq kit covers 200 genes from the major histocompatibility complex. So in that case, you need to process more data in order to get a result. With an exome data set, you'll need to process even more. But because this is a very targeted data set, I don't need to process very many reads to get a result. 10,000 should be enough. So I will click on Finish, and that will then start a new analysis task. As you can see over here, we have one task running, which is the HLA haplotyping task. And what that's going to do is going to do something very similar to here. It's going to run this task in the background, and then when it's finished, we should be able to see some results in this list. Now, we'll carry on, because otherwise I think, here we go, it's finished. So there we go, the task has succeeded. It says that this haplotyping task is finished, and we have a new item in the list here, which is this one. So as usual, I can just select the tick box and either view this result or delete it if I don't need it anymore, or I can click on the item, and this takes you into a sort of a high-level overview of the results of this haplotyping run. So in this case, we have a single sample that we've processed. It's possible to process as many samples as you want within a single run, and there are 2 chromosomes, of course, for each sample, for each individual, and this is setting up this is displaying the haplotype information for this individual. So our haplotyping has determined that the HLA-A allele is O201, and in fact this is a homozygous individual at this location, so he's got the same allele twice. These are the 2 HLA-B alleles. The HLA-C again is homozygous, and HLA DRB1. Now, in fact, we've got a little bit of signal for two other HLA loci in here. We're probably going to add some filtering so that you won't be able to see these. These were not actually included in the sequencing. This one is a pseudogene. So we have got a little bit of result for those, but when we go into the detail, we should be able to see that these are probably just a little bit of noise, basically, in the results. So if I click on the View Result button, this then takes us into a little bit more detail about each of the alleles and each of the loci. And in here we have some tables and some charts for this particular sample, which would show a little bit more detail about the results. So we have kind of three different ways of measuring what we've done for each allele, and also for the exons within the allele. So we have a detection value, which is a kind of a percentage value, which is actually based on a comparison of the density of the coverage that we've managed to achieve for the exons. So generally speaking, a higher detection value of 100 is better than a lower detection value. We have a score. This is actually still being worked on. We're going to be converting this to a score between 0 and 100. The scores are a little bit more widely ranging at the moment. But this score is actually based on a comparison with other alleles for each of the loci. So the highest scoring allele is the one that we report back. If we get more than one allele with the same score, then we will present that as well, because it's an ambiguous result. We're not 100% sure which allele it is. But based on the detection scores and the average coverage, it may be possible to determine which is the correct allele. And the average coverage is the average number of short reads covering an exon or the whole allele. If I scroll down a bit, we can see this information for a particular allele. So this is HLA-A. We've got a very high detection score for the whole allele and for every one of the 7 exons within the allele. These are the scores that we've assigned to the exons. And this is the coverage that we've managed to achieve for each of the exons within the run, and we've managed to cover all 7 exons in this particular case. Now, in this case, we believe this is a homozygous. This is a homozygous locus. So we've only got one allele on the same allele on both chromosomes. For HLA-B, I'll just scroll that so it's a bit more visible. Again, we've got two different alleles here. This is heterozygous in this particular location, and we can scroll down a bit more to HLA-C. For HLA-DRB1, in fact, only one of the 7 exons has been covered by the sequencing. So we've only managed to get a score based on one exon out of 7. So although we've got a very good score for each of the 2 exons within the 2 alleles, this is not quite probably overall as confident as the other loci, because only one exon is covered. So we've also got a chart display, which is a sort of a similar one, but it's nice for comparison purposes to compare alleles. This is slightly more useful when we have an ambiguous result, and then you can compare the 2 alleles sort of side by side, basically, to decide which one is, to help you decide which one might be the right one.